One can use the same procedure that I gave you earlier to graph quadratic functions. In other words, to graph quadratic functions, one would solve for y, make a table of values, plot the points, and draw the curve. Let's look at an example. Let's graph p as a function of x is equal to x squared minus 4. Or, that's the same as graphing y is equal to x squared minus 4. The first step is to solve for y. Y is already solved for. So I'll move on to the second step. The second step is to make a table of values. To make a table of values, I need to choose values for x and evaluate to get y. So we'll let x be negative 2. So we're going to start by just choosing values of x, and I'll start with negative 2. Now you can see the advantage of your function notation here, because when I do the variable as a function of x, then I can simply replace x by negative 2. So you can see I am evaluating the function for negative 2. So I replace x by negative 2. So in place of x squared, I have negative 2 squared. So my function is negative 2 squared minus 4. Now if I evaluate that, negative 2 squared would be a positive 4, because a negative 2 times a negative 2 is positive 4. 4 minus 4 is 0. Next, let's choose negative 1. So the function value for x equal negative 1 would be negative 1 squared minus 4. Now if I square negative 1, I get a positive 1. 1 minus 4 is negative 3. Now I'm going to evaluate the function at 0. Notice I'm just choosing the numbers basically in order. So I'm replacing x by 0. 0 squared is 0. 0 subtract 4 is negative 4. Then I'm going to use 1. Replace x by 1. 1 squared is 1. 1 minus 4 is negative 3. Now I'm going to replace x by 2. So in place of x, I'll put 2. 2 squared is 4. 4 minus 4 is 0. So now we have the table of values. Now once you get the table of values, the next thing you want to do is to plot the points. Now just like before, I'm going to have a hard time plotting the points while we see the table of values. But I'm going to move the table of values over and put them up in the corner as much as possible, and then we are going to try to plot the points on the grid. Now you have x is negative 2 and y is 0. So that means I go over to negative 2, and I do not go up or down any, because x is negative 2, y is 0. Here I have x is negative 1, y is negative 3. So I go left 1 and down 3. Down 1, 2, 3. If x is 0, which means I go left and right none, I come down 1, 2, 3, 4. I go right 1 and down 3. And for this one, I go right 2 and up and down none. So that would be step 3, plotting the points. Now once I get the points plotted, I draw in the curve as smoothly as I can. So there is your curve. That particular curve is called a parabola. That particular curve is called a parabola. All quadratic functions have parabolas as their graphs. Some of the parabolas will open up as this one. Some of the parabolas will open down. But all quadratic functions have parabolas as their graphs. Now let's graph another one. Let's graph f of x is equal to x squared minus 2x minus 3. This is the same as saying that y is equal to x squared minus 2x minus 3. Because remember, f of x does mean y. Well, to graph y is equal to x squared minus 2x minus 3, I need to make a table of values. So I'm making a table of values, x and y. I need to choose values for x. Now I normally start with -2, -1, 0, 1, and 2. Now when I'm graphing parabolas, I may need a lot more points. Now if x is -2, we would have y is equal to a -2 squared, subtract 2 times a -2, subtract 3. Notice I'm replacing x by -2. I have x squared, so I'm replacing x by -2. I have -2 squared. Subtract 2 times, I'm replacing x by -2, subtract 3. Evaluating, a -2 squared is 4. A -2 times a -2 is a positive 4 minus 3. 4 plus 4 is 8. 8 minus 3 is 5. Now here we have y is equal to a -1 squared minus 2 times a -1 minus 3. Now -1 squared is positive 1. A -2 times a -1 is a positive 2 minus 3. 1 plus 2 is 3. 3 minus 3 is 0. In reality, I probably should be just putting in the parentheses first, as I told you in an earlier tape, and then go back and put in the value of x. Now in this case, the value of x is 0. Now 0 squared is 0. A -2 times 0 is 0 minus 3. And then 0 minus 3 is -3. Now I'm going to do 1. So I have y is equal to something squared minus 2 times something minus 3. And that something is 1. 1 squared is 1 minus 2 minus 3. 1 minus 2 is -1, minus 3 is -4. Finally, we're going to do 2. Y is equal to 2 squared minus 2 times 2 minus 3, which is 4 minus 4 minus 3, which is -3. So now we have a partial table of values. I think in this case we're going to need more. But let's go ahead and plot the points that we have. And if we can see the parabola, we'll be through. If we can't see the parabola, we'll have to pick more points. To plot -2, 5, I go left 2 and up 1, 2, 3, 4, 5. To plot -1, 0, I go left 1. To plot 0, -3, I go down 3. To plot 1, -4, I go right 1 and down 4. To plot 2, -3, I go right 2 and down 3. Well, some of you may think you know what the parabola is going to look like now, but really, we do not have enough points. Let's choose a couple more points. Now, obviously, I don't need to pick more points over here, because I can see on this side that thing is just going up. I need more points on the right. So to get more points on the right, let's go over and let x be 3 and let x be 4. So let's go ahead and choose 3 and 4 as values of x.